Welcome to Pomodoro Joe for Sunday, June 4th, 2023. Today we're doing LeetCode problem 547, number of provinces. This is a medium problem. There are n cities, some of them are connected while some are not. If city A is connected directly with city B, and city B is connected directly with city C, then city A is connected indirectly with city C. A province is a group of directly or indirectly connected cities, and no other cities outside of the group. You are given an n by n matrix, is connected, where is connected index ij is equal to 1 if the ith city and the jth city are directly connected, and is connected ij is equal to 0 otherwise. Return the total number of provinces. And then we have some examples. So 1 and 2 are connected, but 3 is not. So we should have 2 provinces. Looks like we have 2. 1, 2, and 3 are all not connected, so we should have 3. All right. Okay, so we will put 25 minutes on the Pomodoro timer and we will get started. So this one is actually a perfect candidate for the union find. Now, union find is a new tool for me. I haven't used it that much, so I might not make this the most efficient union find, but I'll give it a shot. So a union find is also called a disjoint set. So in this problem, we are told to find basically how many different graphs there are in a set of nodes and connections. Now that is the perfect type of problem for a union find solution or a disjoint set solution. So essentially we're looking for sets of connected cities and we're trying to find how many of those sets there are, hence the name disjoint sets. These are different sets of connected cities. Okay, so with our union find, there are basically 3 pieces. There are 2 functions. One is called union, the other is called find, and the other piece is some storage where we store a mapping of our city to our province. So let's start with our storage. All right, so this is going to be our province storage, our province mapping. So our provinces will equal, so we'll basically have 1 province per city to start with. So this is like this example here. Every city will basically be its own province. This is our base state. We'll have every single city mapping to its own province. Then we'll start merging them together or unioning them as we go along. So for every city, I guess we're going to need to know how many cities there are for x in range n. All right, so I need to calculate the n. They're not giving us n, but our n should just be the length of our is connected graph here. And then our provinces will start for every x in the range from 0 to n. Then we'll have basically 1 will map to 1, or 0 will map to 0, 1 will map to 1, 2 will map to 2, so on and so forth. Oh, that actually brings up a, It says we have n cities. It doesn't say they're labeled from 0 to n, but it looks like they might be because they're starting with 1. Let's look at our constraints. Yes, so n starts at 1 and goes to 200. So we probably want to go through n plus 1 here. So our 0 index will basically be a throwaway. It's just padding so that we can map an index, which will be the city number, to 1 entry in our province array here. All right, just to explain this one more time. So I'm adding 1 to our n here because we have a mapping of city numbers that's 1 through 200. And we want to use the city name or the city number as our index into the array. Since there's no 0 indexed city, we basically will pad our array here with 1 extra value. So that's our 0 element. Then everything else will go from 1 through n. All right, so this is our storage. This maps our city to its province, and it starts out mapped to its own province. Next, we need to define our union find here. So we'll define our find. So our find will take the city, and it will return the province that the city belongs to. So first we'll check the province. Maybe I should take a second to explain the union find a little bit before we write more code. So the way the union find works is we break it out into 2 functions. One is find, which will return the province for this city. The other is union, which will take 2 cities and will combine them into 1 province. Depending on the way we implement our union, this province that's stored as the province for our city might not be the root province or the overall umbrella name for the province. So what we need to do is follow the trail of cities on up till we find the root of the province. So for example, we could have, let's just go, pretend this is our array. We have 1, 2, 3, 4, 5, etc. Those are the city names. And their values might be 1, 1, 2, 3. So if we look at city 4 might look like it belongs to province 3, but it's just saying it's connected to city 3. So we look at city 3 is connected to city 2 is connected to city 1, and city 1 is connected to itself. So that is going to indicate that this is the top level or the root of our province. So we'll need to follow our trail back up to the root of the province. And we know we find the root of the province when the city and its number, its province, are the same. All right, so let's back this up. So we're going to grab the province from our provinces for the city. Now, if it matches the city, well, then we're done and we can return. So we can just say if the city is equal to province, then this is the root of our province. So we just return. We can either return city or province that are the same. Otherwise, we need to follow our route up the chain till we find our province. So then we return find on the province. Okay, so this is our find. Pretty straightforward. That will give us the province that this city belongs to. Next, we need to define our union. This will take two cities, city 1 and city 2. All right, so for the union, let's find the province of the city. So we can just use our find function for that. So the province for city 1. Next, we'll find the province for city 2. We can either find the province or we can just grab the value from our province array. Let's just grab the value here. So the next city, that's just going to be province for city 2. So we will be merging the province for city 1 and city 2. Now we have to choose one of them to be the overall province. So I'm choosing city 1's province to be the one that absorbs city 2's province. Now city 2, we could find the province, but then we'd have to go through and directly modify a bunch of values. We'd basically have to search for all of the cities that map to that province. What we could do, we just start with city 2 and follow its chain back up to its root province, changing each one of their references to the province along the way. So we're basically modifying the chain from city 2 back to its root. So the first thing we'll do is we'll change the province that city 2 is referencing here. So the province for city 2, provinces for city 2, will now point to this province. So the province for city 1. So now we've made city 2 part of the city 1 province. Next, we need to go to the next city that's in city 2's chain and change its province. So we can just call a union on that. Now, we do want to check to make sure that it's not already in the province. So let's just make sure that we don't have the root here. So if our next city isn't the province itself, then we'll just union these two. All right, so we'll put the next city into this province. So I think this is it. We'll grab the province for city 1, then we'll go through and change all of the chained cities from city 2 up till its base province, and we'll change those to city 1's province. Okay. So I'm sure there's a cleaner way to do this, but this is the way that just comes to my mind. So this is our union find. Now that we have a union find, we need to actually go through all of our cities and start doing the union find algorithm. So for every I in range n, actually it should just be from 1 to n, I guess. Well, no, we'll go from range n. And for j in range I to n, I guess we can go I plus 1, can't we? Yep. So this should cut down a little bit of processing. So we're going through every city and then every other city that we actually haven't checked yet. So we'll go from I to n, and we'll go from j to range I plus 1 to n. Then we will just check to see if they're connected. So if these two cities are connected, and if they are connected, then we'll union them. We'll go I and J. All right. So we'll go through. For every two cities that are connected, we'll union those two cities. So we'll try to get one province for them. Now that we've gone through every city, found all these different unions, now we need to go through and actually find how many unique different unions there are, or different provinces there are. So we'll have some count, or maybe we'll call it province count. Start it at 0. All right. So how do we find how many different provinces there are? Well, we know that the province root will be where the city is matching the province value. So the city index, the index matches the value. So we can just check to see the provinces at this index is equal to the index itself. That'll be the root of our province. And if we find that, we can just add one to our count, our province count. Well, we can do that. And at the end, we will return our province count. All right. So I think this should do it. Again, union find is something that I'm fairly new to, so you might want to check this one out. I'll leave a link in the description. Provinces, plural. All right, I think that should do it. The wrong kind of brackets, man. So many problems. All right, some typos there. Let's see if that works. Okay, that seems to work. Let's see if we can pass. And we pass. And we do pretty well, actually. We beat 85% for runtime and 57% for memory. That is not bad at all. Now, there are things that we could do to speed up our union find. One thing that I've seen is in the find itself, you can start modifying as you're doing the find. You can start essentially merging the different, how do I put this? As you're doing the find, you can actually change the values as you work your way up the chain to actually match the province that they all belong to. So instead of having to go through the entire chain again, you basically can just check the index directly to get the province for this city. Now, I don't particularly like that solution just because find, I think, should be an immutable type function. It shouldn't be changing your provinces here. But that's just a quirk of mine. I don't think that's necessarily right or wrong. I just have a feeling that find shouldn't be modifying the underlying data. However, it could speed things up, so it might be worth a shot. Okay, well, that is it for me. I will leave a link in the description for the union find. You can check it out. And yeah, if you like this video, please give it a like. All right, that is it for me. I hope you had fun. I hope you learned something. I hope you can go out and write better code.